All right, quick lesson to get to today, section 3.3 is not too bad, just one-sided for my guided notes. And again, it's very extremely similar to what we've done already. Like for example, if I gave you this problem, if I said 3x is equal to 12, how would I solve that little equation, 3x is equal to 12? What would I do? Mackenzie? Yeah. So x is equal to 4, right? Guess what? If I make that an inequality, the rules remain the same. Okay? We interpret our answer a little different, and we might have to graph on top of it, but the rules remain the same. Okay? The rules remain the same. Remember, solving inequalities is extremely similar to solving equations. To solve an inequality that contains multiplication and division, you undo by taking multiplication and division, the inverse operation. Now, the following rules show the properties of inequality for multiplying and dividing. Positive number. The rules for negatives are a little weirder. We'll talk about those in a minute. So, let's get to it. 7x is greater than negative 42. Guys, what do I do here to solve this inequality? Travis?
Divide by 7.
Divide by 7. So I get x is greater than what? What is negative 42 divided by 7? Negative 6. Okay. What kind of graph do I have down below? I don't like those graphs. I'll make my own. We got negative 6 and 0. Open or closed circle on 0. Or sorry, on negative 6, excuse me. Open. Going to the right. Good. Again, that means that any value that's being covered up by my arrow is a solution, like 0. If I plug 0 back in, 7 times 0 is 0. Is 0 greater than negative 42? Yes. And you can always check your answer in that way. Take a look at the next one there. The next two, I guess. Hey guys, what would I do to get m alone in part B? Dude? Well, I'm already dividing by 3. Multiply by 3, right? Multiply by 3. Multiply by 3 here and here. Okay, let's take 2.4 times 3. Oh, I can do that.
7.2.
7.2, that's right. 7.2. You do that in your head, or do you have a calculator? 7.2 is less than or equal to m. How am I going to write this answer? How would I write this answer? Would I leave that like that?
No, you change variable to the side.
Yeah, I'd move the variable to the left side. I would say m on the left side, 7.2 on the right side, and now this symbol goes from less than and turns into greater than. Okay, that's how I would write this problem. Now, if you put, see, I would box that answer. If you put this answer on an answer blank, I will still give you credit for it. However, be careful how you graph it. Okay, be very careful with how you graph it. We've got 0 and 7.2. Is there going to be an open or closed circle on 7.2? That should be the same. Closed should be the same. Now, which way should the arrow point? To the right. Not to the left, but to the right. See, maybe, or maybe you're smarter than that. Maybe if you boxed the purple answer and put that on the answer blank, maybe you made it go to the left. But that would be wrong, right? That would be wrong. The answer is greater than or equal to 7.2. Remember that you can always check an answer by plugging in a value that's covered up. Like if I did have it going the wrong way, 0 would have been covered up. 0 divided by 3 is 0. Is 2.4 less than 0? No, it's not. So therefore, I would be, I'd know that something was wrong there. All right, what would I do for R, to solve for R? What would I do to solve for R? Hey.
Multiply 4 by 12. Or sorry, divide by 12.
I would divide the whole 3/4 over to the other side. Yeah. I would divide the entire 3/4 over to the other side. Now be careful how you use it in your calculator. We're going to do 12 divided by, I have to do special parentheses here, 3/4. 16. R is less than 16. Now, here's 0 and here's 16. Is it an open or closed circle?
Yeah.
Open circle. Going to the left. Okay. Questions about that? People, make sure that when we get to quiz and test time, you don't just write 16. Oof. You need to put the symbol there as well with the variable. Like on our chapter 2 test, if we were just solving an equation, would it have been okay to just write 16? Yeah, that would have been okay. But now we must include the symbol as well. Okay. Let's take a look here. Now let's talk about our negative rules. Our negative rules. Star this, highlight it, underline it, whatever you need to do. If you multiply or divide both sides of an inequality by a negative number, and I would like you to underline the word by. If you divide by or multiply by a negative number, the symbol needs to be reversed. Okay, the symbol needs to be reversed. And be careful knowing the difference here. Yeah. If I have this, let's use this, like 2x is greater than negative 6. Guys, how would I solve that inequality? How would I solve that inequality, Nate?
Divide 2 by negative 6.
I divide by 2, right? I divide by 2. The thing that I move across the inequality is positive. Do I change the symbol? No. The symbol does not change. This is x is greater than negative 3. Just because you see a negative doesn't necessarily mean the symbol flips. An example where the symbol is going to flip is if I move the negative number. What if the negative was on the left side over there? What if it was next to x? Well, now I have to move negative 2. That's an example where the symbol is going to change. I move the negative across the inequality, the symbol must change. X is now less than negative 3. Do we all see how the symbol flips there? You don't change the or equal to piece of it. The only thing you change is greater than to less than or less than to greater than. Okay. All right, so let's test that out a little bit. Negative 12x is greater than 84. Negative 12x is greater than 84. Okay, what solves this inequality? What solves this inequality? Ooh, somebody I haven't talked to yet today. I've talked to you, Tyler. Somebody I haven't talked to yet today. Elena, thank you. Good, divide by negative 12. Divide by negative 12. Now, when I divide by a negative, does my symbol flip? Yes, the symbol flips here. I'm moving the negative, so this greater than turns into a less than. Let's take 84 divided by negative 12. That's negative 7. So x is less than negative 7. Here's my graph. Here's negative 7. Here's 0. Is it going to be an open or closed circle on negative 7? Open. Now, is it going to go to the right or to the left? To the left. Even though in my original problem it looks like it would have gone to the right, it had to flip because I divided by a negative. Don't believe me? Plug and answer it. Like plug in, I don't know, negative 10 would have been a solution, right? Negative 12 times negative 10 would be a positive 120. Is 120 greater than 84? Yes, that came out to be a true statement. So remember, you can always plug in values just like we did on the last chapter test. Take a look at these ones here. What solves this first one? What solves this first one? What do we do? Yeah. Good. Now I'm multiplying by a negative. I am multiplying by a negative. Multiply by negative 3. Multiply by negative 3. Negative 8 times negative 3 is a positive 24. The symbol has to flip. It was a less than or equal to, and now it turns into a greater than or equal to. And the negative, the times the negative 3 cancels out on the right side. Now, this is kind of a tricky one. This is kind of a tricky one because what am I going to do to my answer now? I'm going to flip it back, aren't I? I'm going to put x back on the left side and 24 on the right side. I guess it was never on the right on the left side. But I'm going to put x on the correct side, on the left side. And I'm going to move the number. So what happens to my symbol again? It changes one more time, yeah. Again, would this have been an acceptable answer? Yes, that is technically a correct answer. You should be very careful when you graph it. I will always write my answers with the variable on the left so that I can graph it. I've got 0, put 24 way over here. Open or closed dot on 24? Going to the left. See how it's covering up 0? Let's test 0. Let's plug 0 back in. 0 divided by -3 is 0, right? 0 divided by any number is 0. -8 is less than 0. Is that a true statement? Yes. -8 is less than 0. I know that I got this problem right. Okay, so this weird problem where we just have a negative on the other side, right? What do we do? What's the formal thing to do when we want to get the negative to go away? Anybody remember? What's the formal thing that we have to do? I know we move the negative over to the other side, but what operation are we really doing? Big? Division. I'm actually doing division by -1, aren't I? That's the thing that gets the negative over to the other side. Oh, chicken nuggets, look what happens then. The symbol has to flip. Okay, watch out for that. It's not just as easy as just moving the negative over to the other side with an inequality. The symbol actually has to flip as well. And then again, this is one of those funky ones where I'll put my variable on the left side. That's my answer. Here's -10, here's 0, closed dot, going to the right. Again, if you're ever questioning yourself, plug in a value. It's going over 0, plug in 0. 0 is always the easy one to pick. That's why I make you put it on there. It's going over 0. Okay, -0 is just a 0. Is 10 greater than 0? Yeah. I know 0 is a valid answer. Okay, let's take our word problem here. Jill has a $20 gift card. Ooh, another gift card thing. Jill has a $20 gift card to an art supply store where 4-ounce tubes of paint are $4.30 after tax. What are the possible numbers of tubes that she could buy? All right, well, if she's got a $20 gift card, can she spend $21? No. Can she spend 19? Yes. Can she spend 20? Yes. Think about the different possible outcomes. Whatever I buy on this side has to be less than or equal to $20. So let's put the amount that I'm going to buy on the left side. Okay, what is that then? Well, I have tubes of paint, and they are $4.30 each. Okay, and we're defining our variable to be x. I should have wrote t. X for the number of tubes of paint. Okay, so what solves this inequality then? Nate?
I would divide 430 on each side.
Yeah. Divide by 4.3. X is less than or equal to 20 divided by 4.3. 4.65. Okay, what does our answer really mean? Mackenzie? Good. Yeah, she can buy up to 4 tubes. Why don't I round up? 5 and above, give it a shove. Why don't I say 5 tubes? Can she purchase 5 tubes?
No.
No, she doesn't have enough money to purchase 5 tubes. So you actually have to round it down in this case, because I want less than or equal to. So 4 tubes, and we'll say 4 less. That's a B and an E there. A B, oh, that's not it. Tubes of paint. 4 less, right? 4 less. She could buy 3. She could buy 2. She could buy 1. But if she wants the most number of tubes, it would be 4 that she could purchase. Again, she cannot, can I say less than or equal to 4.65 tubes of paint? No, you're not gonna walk up to the register and be like, oh, can I get 0.65 of this tube? Can you cut it for me, please? They're gonna be like, they're gonna look at you weird. All right, that's it for today. Let me stop the video. Okay, so here's what's gonna happen